Assalamu alaikum. So the third type of transformation that we are going to do today is stretches. Again, the stretch can be done along the x direction. It can be done along the y direction. So what is the difference between the two? For x direction, for the x direction, it's f a of x. It's a stretch with factor 1 by a. It's a factor 1 divided by a in the x direction. And in the y direction, it should be a times the function x, a multiplied by the function fx, which is going to be the stretch with a factor a in the y direction. So these are the two differences between the stretch in the x direction and the stretch in the y direction. In the x direction, we have to divide the x roots by a. In the y direction, we have to multiply by the x roots by factor a here. So let's do an example to clarify the concept. Let's say that the basic quadratic graph is such that the function is intersecting the x-axis at -2 and a +2, having the y-intercept as a -4. This is a basic quadratic graph with root as -2 and 2 and the y-intercept as -4. Let's transform it for stretches along the x-axis and along the y-axis. Now, let's say we have to stretch or transform this function, the given graph over here, so that now it is f of 2x. So what I can see here is that there is a stretch factor 2, which is within the function, f of 2x. Therefore, the x-intercepts here, for the x-intercepts here, I should say that it's plus minus 2, both the x-intercepts, they should be getting divided by the stretch factor, which is a 2 in this case, so that I can say that this can be equal to a plus and a minus 1 here, meaning the two roots, -2 and 2, after the stretch transformation shall be -2 divided by 2, giving me a -1, 2 divided by 2, again giving me a +1 here. So the graph of the function that I should be having is, for f of 2x, is going to be of this shape with the x-intercepts reduced to -1 or stretched to -1 and a +1, the y-intercept remaining the same. Therefore, this is going to be the transformed functional graph for f of 2x for the given f of x graph over here. Let's do it along the y-axis. So along the y-axis, it's 3f of x. There is a 3 outside the function. That means that along the y-axis, the graph needs to be stretched by 3 units. So by 3 times, not 3 units, but by 3 times. So over here, what I can see for the basic graph is that the only y coordinate that I have is a -4. So this -4, I should simply multiply by 3, -4, which is the definite y coordinate that I know. The graph is going to get stretched along the y-axis only. Therefore, it's the y coordinate -4, which gets multiplied by 3, which is the stretch factor, giving me a -12 here. So the shape of the graph after the stretch of factor 3 along the y direction shall be -2 and 2 remaining the same, no change over here. -2 and 2, no change here. And along the y-axis, I can see that the graph has stretched by -12 along the y direction. So this is going to be the shape of the graph after the stretch along the y direction with the stretch factor, which is a 3 units. So -4 multiplied by 3, giving us a -12. This is how my graph will get stretched for the given functional graph over here. So this is the explanation for the stretch transformation for functions along the x and the y direction. So let's do some composite questions to clarify the concept. graph of y equals fx is transformed to the graph of y equals negative f2 of x. These are the two important things that we should be looking into. It's a negative f2x. Describe fully the two single transformations that have been combined to give the resulting transformation. So what we have seen here is that there is a stretch factor 2 f2 of x within the bracket. So with that, I should know that it should be the stretch, it should be the stretch in the x direction with stretch factor, which is going to be always in this x direction. I have to write the stretch factor as a reciprocal of 1 or an inverse. So I would say with the stretch factor 2, and then the negative sign outside the function that shows that it's also getting reflected. It's getting reflected in the x-axis. So these are the two single transformations that have been combined to give the resulting transformation over here. So this is how we shall be describing the transformation for this question. Let's do another question. The curve shown has a maximum point at a 1 negative 1 comma 4 negative 1 comma 4 and a minimum point at b, which is 2 comma negative 8. On separate diagram sketch. Now there is part A which says y equals fx plus 4. So let's start with that. So it's a very simple question. A f of x plus 4, part A, it's y, which is equals to the function, and then it's just a simple translation here. I can see that f of x, it's the same function, but there is a constant which is a positive 4. So it's going to be the translation along the y-axis for 0 comma 4. Therefore what I should know is that for all the vertical coordinates or the y coordinates, what I should know here is that this 4 value, let's write it with a different color, this 4 needs to get translated by another 4 units. So that means if over here this was at 4, then it needs 4 more units need to be added, meaning it should go to positive 8. From 0 it should go to positive 4, meaning it should come here as a 4. 3 should also move to 4. My negative 2 should also move to 4, and negative 8 moving by 4 units, it should come to a negative 4 here. So for the same function translated by 4 units, I should say that my new graph is going to be by 4 units, giving me an 8. From 0 it shall move to 4 units upwards, so that's a 4 here, and from negative 8 it should move to negative 4. So this is what we had initially. Negative 8 moved upwards by 4 units, so it's a negative 4. 0 moved upwards by 4 units will come to positive 4, and then 4 here moved upwards by 4 units, that will go to a positive 8. So I have marked all the y coordinates which needs to shift upwards by 4 units. Then the shape of the graph, negative 2. Negative 2 now should be at a positive 4. It was a negative 1 and a 4. Now this negative 1 and 4, it should move to a positive 8. 0, 0, it should move to 0 comma 4. Negative 2 and positive 2 and 8, this should move to a negative 4. Initially it was a positive 2. This point, the point B, I'm talking about point B, which is 2 comma 8, this should move to 2 comma negative 4, and then it's 3 comma 0. Now this should move to 3 comma 4 here. So the new graph is going to be such that it has moved upwards by 4 units, so that this is how the new graph shall be. So this is going to be the new graph after the translation of 4 units in the positive y direction. So this is the new graph that we shall be having here. Now going back to the question, it says it should be for y equals 1 by 2 f of x. Now y equals 1 by 2 f of x means that there is going to be a stretch, and this is a stretch along the y direction, so that all the y coordinates, they should get multiplied by 1 by 2. It's a stretch factor of 1 by 2 in the y direction. Therefore, we'll say that all the y coordinates will get multiplied by 1 by 2. So let's do this part also. So here it's a 0, 0, and then 0. The 3 roots, obviously they are not going to get affected. But this 4, for this 4, I should simply say that this 4 and this negative 8, they should get multiplied by 1 by 2, meaning 4 into 1 by 2, that will give me a positive 2, and negative 8 into 1 by 2, that would give me a negative 4 here. So the stretch factors, they should now be such that if I sketch the graph, I should say that this is a negative 2 here, and then for negative 1, it comes to a positive 2. So A has been transformed to negative 1 and a positive 2. Origin, obviously 0, 0, that remains the same, with 2 doing for point B, negative 8 times 1 by 2, that is giving us a negative 4. So we have a negative 4 here, and this B prime shall be 2 and a negative 4. For 3, obviously it will remain the same, 3 comma 0, because 0 times 1 by 2, that will give me a 0 again. So to sketch the graph, I should simply say that my new graph here is going to be this graph with the transformation. So this is how I will be sketching my new graph here. So this is what the transformation is with respect to the stretch and the other transformations that we have done earlier. So in the next video, I will be covering all the past paper questions regarding transformations.